Newton's third law says, oh, you ready? Oh, you didn't know there'd be a test. Okay, Newton's third law says, for every action, there's an equal and opposite reaction. That's right. Now let's see what he was saying. What is an action? What is a reaction? It's a force, isn't it? What Newton was really saying is that for every force, there exists an equal and opposite force. Forces occur in pairs. And just like all of science, this occurs in our daily lives and on very simple levels. See, I need, 3 or 4 or 5 volunteers. We're going to blow up some balloons. Who's really good at blowing up balloons? Okay, all these folks, and over here, come on up, and we're going to line up right in front of the table here so the camera can catch you. Let's see, while you're blowing up the balloons, we've got here Kimberly, right, and Gary, Charles, Willie, and Juan. These are our balloon experts. All right, let's everybody blow up your balloon. Very colorful here. That's great. And hold them out. And when I say go, you release them. 1, 2, 3, go. Whoa! What happened? They move. Okay, let's give our volunteers a hand. Now, why did those balloons fly all over the room? What was happening there? What does that have to do with physics? Well, when they released them, what came out one end of the balloon? Air. All that air. So that was a force moving in that direction, and what happens to the balloon? It moves in the opposite direction. Now you see this, and that's Newton's third law. Now, you see this on a giant scale every time you see a rocket being launched on TV. Think about what that looks like. In order to launch the rocket, what do you see coming out the bottom of that rocket? All those, gases, all that exhaust. And think about why the rocket takes off. The exhaust moving in one direction makes the rocket go in the opposite direction. For every force, there exists an equal and opposite force. You know, a lot of people think that when the rocket takes off, the gases push against the ground and push the rocket off. But if that happened, how would it get back from outer space? There's no ground to push on. So it's just Newton's third law. The gas is escaping from one side. The force causes an equal and opposite force to push.